Hey everyone, welcome back to my shop. It is me, Rob, and I want to start off by saying I realize this is going to be a long video and I apologize for that, but this is a big topic with a lot of information and I tried as hard as I could to be as concise as possible. That being said, I did work very hard to make sure that this is an enjoyable viewing experience for you guys out there, so I want to say thank you so much for watching this video. I really hope it helps you guys out there on your woodworking journey. So with that out of the way, let's roll the intro. When it comes to MDF doors, the shaker style is no doubt one of the most prolific designs out there, and that is for good reason. It looks nice and it's relatively simple to set up, but eventually you might come to a point to where you want to offer a little more to your clients than just the simple shaker door. And so that leads you on the path to start adding new tooling to flavor it up, so to speak. So in this video, I'm going to walk you through how I set up an inner bead, or like an inner rollover, whatever you want to call it, on the inside of an MDF shaker door. So I feel like it's the next logical, technical progression, without getting too crazy. We're going to take a standard shaker door. We're just going to add a little profile to the inside. So with that being said, let's take a look at the tools that I'm going to be using. First one right here, we've got a diamond blade hogging tool. And this has been a fantastic tool that I've been using for a couple years now. And I purchased this one from Dylan over at Mid-America Woodworking Machinery. And I've just been really happy with it. So we're going to use this to do our main hogging. All right. To get our shape in the center, we're going to be using these two tools here. And these are both from Vortex, and they need to be bought together. These are made to work together, and I think these actually come from the raised panel kit, but I'm not using the actual raised panel part of it. We're just using these for these inner bevel, and I believe it's from the raised panel kit. But the reason that these have to be bought together is because this guy goes first and starts removing the bulk of the material, starts giving it the shape, and then this guy comes behind it with the nice point and cleans it up. So there's probably other tools out there that will accomplish the same thing. I just happen to be using Vortex tools because I have them on hand. All right, the next one, we're going to be using an 1/8 inch end mill, and I don't even know what brand this one is, and I don't think it matters. I think wherever you get an 1/8 inch end mill from probably will do the trick. probably work just fine. So we're going to use this to clean up the corners on the inside. And then to cut it all out, Nick Frost over at Frost CNC, he sent me a couple of these 3/8 compression bits to try out. And so we're going to use this one. I've been using it for a couple weeks now, probably almost a month now. So far, I've been really happy with it. So thank you to Nick Frost for providing me with this compression bit. So the first thing that I do when I am trying to figure out what door profile to start experimenting with, first thing I got to figure out what I'm going for, and then I start hunting down, what tools I'm going to use. Once I do that, I get I order my tooling, my collets for the shank diameter. I get them set up in the tool holders. I use a tool setter. I get all of them set, and then I put them in the machine, and that is like the first step I always do. So I always work on the machine side first, getting everything set up, and then once I get to this point, then I can jump into Cabinet Vision and we can start setting up the tool sets and start experimenting with the doors. So now that I'm at this point, let's jump over to Cabinet Vision and start getting these tools put into Cabinet Vision, and then we're going to start building a set out of them. So let's go into Cabinet Vision. So now that we're inside of Cabinet Vision, there are a few things that I need to do, but the first one I'm going to focus on is getting each individual tool set up in the tool catalog, so that way Cabinet Vision knows what we're talking about when we go to build the sets. So to do that, I'm going to come up here to this tool icon, and it is going to bring up our tool catalog. And if you've never put anything into the catalog before, it can be kind of overwhelming, but I'll try to go slow and explain everything that I'm going to be doing. And I just want to throw out a disclaimer. I'm self-taught, and so everything I know is from what I have de-engineered throughout the years. So there may be better ways to do things. This is just what I have found that works for me. So just keep that in mind. So we're going to focus on the easier tools first. And so this hogger and then the 1/8 inch end mill. When it comes to bringing a tool into the database, there are two ways to do it. The first one, we can copy a selected tool. Maybe you already have a bunch of tools in the database, and you might have one that's close or close enough where you can copy it and then modify it, or you can just create a new tool from scratch. And so that's what we're going to do. Let's create a new tool, and now it's going to ask us to name it. And so I try to name my tools very deliberately, and I would strongly advise you to do that as well. So as time passes, you can always look back and you know exactly what tool it is based on how you name it. So the first thing for me, I always put the slot the tool is going to go into first. So in this case, tool 11, because it's going into holder number 11. And then I'll name it something specific to the tool, like I could say diamond hog, something like that. And that way I know when I see it, I know it's tool 11, and I know it's my diamond hogging tool. And just for this video, I'm going to come and put DEL in front of this because I need to go delete this because I already have this tool in. All right, so now it's going to ask us for a type, and I'm going to select flat router because that makes the most sense. And this categorizes all your tools based on what they are, so you can do a quick search if you have a lot of tools. So we'll just leave it at flat router, and then it's going to bring us to this window where we have to start putting in information about the tool. So we're just going to go top to bottom. So the first one, machine, I am going to leave that on any, and this allows all the available machines that you have integrated in can use that tool. And then you have unavailable, which basically blocks it out. Cabinet Vision won't use it. So if you're like experimenting with a tool and you don't want anyone to run it, you would go unavailable. But we're just going to leave that as any. Here we have the name. You can rename it if you want to, or change the name. And next we have tool number. And so just like the name, it's going in slot 11. So I'm going to put tool number 11. And then in my offset height ID, I also have to put 11, and I have to make sure these numbers match. All right, so we have tool ID next. It's grayed out, which means we cannot change it. And what this is an identification that's assigned to this tool, and you would use this in a custom UCS if you wanted to reference this tool. So that is what that is for. All right, next we have tool size, and it starts out with a 1/2 inch diameter by default. And whoop, the phone's ringing. Let me give it a second for these. Sorry about that. All right, so this is a 1/2 inch diameter, but this one is actually, it's 1.25 inches or 32 millimeters if you wanted to switch to millimeters. But so 1.25 inches there. Minimum work depth, we're going to leave it at 0 because we wanted to work at the surface of the material. And then by default, the work depth is set on 2 inches. And I'm not going to go anywhere near 2 inches with any of the doors that we do. So I'm just going to leave it at the defaulted 2 inches for now. So if we come down here, we've got Tool Auto Select. And if we read down here, it says include tool in the auto select routine. And basically that just gives Cabinet Vision the ability to search all available tools in the auto select pool and then choose whatever it deems more appropriate to complete a task. So I always leave that checked yes. Outline tool, I am also going to leave as yes, and then leave the rest as yes as well. Movement, I'm going to leave this at offset tool comp. I'm going to keep that as yes for rotate clockwise. Max depth per pass. Defaults at 3 inches. Obviously, we don't want this to go down 3 inches for the max depth. That's way too deep. And these blades are 1/2 inch, so I'm going to set this as a 1/2 inch. And the MDF doors that we're going to make, it's not even going to go that deep, but we'll go ahead and set that as a 1/2 inch. So this add to through cut. Okay, so this is when the tool is going all the way through the material. And if you leave it at 0, basically the idea is it's going to go all the way through the material and stop at the surface of your spoil board. And if you add a positive number to that, let's say you went like a 16th or something like that, it's saying go through an additional 16th into the spoil board to make sure you get a good clean cut. Or we could do something like add a negative sign to the front of this, and then it's going to raise it up and give you like an onion skin. So that is just something to keep in mind. On this hogging tool, we're not going to go through on at least nothing that I do. I go all the way through, so I'm going to leave that at 0. All right, so the feed rates. So on the 1/4 inch feed rate, I'm going to put this at 240 and then 120 for all of these. And I'm going to leave my spindle speed at 12,000 RPM. So these feeds and speeds I kind of took from programs that I had seen Cabinet Vision techs set up for people. So I don't really have a lot of insight as to like what, like why they arrived at these numbers, so to speak. I just know that this is what I have seen them set up in the past. So I just roll with that. And right here on this CAD, you can change the colors of the operations if you export a DXF file, if you want to color code your lines. But I don't really do that, so I don't mess with that. And then I don't have a 4th or 5th axis router, so I don't mess with that. All right, so that is the bulk of the information here. But there's one last thing we need to do, and that's edit the shape. And if we click here, we have the shape editor. And the reason you would want to edit the shape, make sure it's accurate, if you do a lot of like simulation with XSim, you can get it pretty accurate. So you can do a lot of your building in the simulation, and then you can go to the real world and you have a lot of the kinks worked out. It gives you a good starting point. If you're not very good at this and you don't have super accurate drawings, it's not the end of the world. It just means you have to do the most of your testing in the real world with the actual physical shape of the tool. So inside the tool shape editor, I'm going to admit that I do not like this. I feel like it's kind of unintuitive, but we're just going to do the best we can. So here is our tool, and I'm going to throw a picture up on the screen, and you can see that if we take a look at the tool, we've got 1.25 inches in diameter, and then we've got a 3/4 inch shank, and then our tool height is a 1/2 inch, or the blade thickness of the blade is a 1/2 inch. So how do we recreate this inside this tool shape? And so currently, if we look over here, our grid unit is set at 3/16, and that means that these are 3/16 by 3/16 squares. And so what we're going to do is we're going to change these grid unit sizes a couple times to accomplish what we want. So the first thing we're going to do, let's tackle the width of this tool. And so what we're doing here is we're only drawing the right side of the tool. So we're going to draw the right side of the tool, and then the cabinet vision will apply that to the left side. So if our overall diameter is 1.25 inches, if we come over the radius of that, which is 0.625, I believe. Let me look at my trusty metric conversion data. Yeah, so 5/8 of an inch. We're going to come over 5/8 of an inch, and we're going to make these squares is what I'm doing, 5/8 by 5/8 squares. Okay, so that gives us our diameter, and then if you add, we're going to draw this right side, and then if we add it to the left, we will get our 1.25 inch diameter. So right now we're already good with our diameter. So now we need to come up a 1/2 inch because that's the thickness of our blade. So I think, let me just check something real quick. Okay, so if I change this to 1/2 inch by 1/2 inch, we can see that this stayed at the 5/8 point, and I believe it's because when we put in the tool diameter here, I think that is driving where it initially starts out the width. Okay, so now we can add a point here, and you click that, you click the dotted lines, and it allows you to add a point. And we're going to, we got to turn, so one thing we've got to do is we've got to turn off this snap to grid, because it's going to want to snap only to the grid points. And we don't want it to do that. So let's put that about right there. All right, and now, so that is the height of our tool blade. So now we need to come back this way, but we need to come back this way half of the shank, which is 3/4 of an inch. So we're going to come over 3/8 of an inch. So that is 0.375. Okay, so if we do that, now we can come all the way to this point here. So let's do just like that. And then let's move this guy in line just like that. And that is pretty much it. And it's pretty straightforward when you're doing these square shapes. It can be pretty annoying, but if you experiment with it and you mess up, just hit close and just say no to this save tool shape, and you can start over. But in this case, we're going to say yes. And we have our tool shape that's pretty accurate for the diamond hogger, and we can use this in the simulation. So now that we've got the hogging one out of the way, let's move to the 1/8 inch end mill, and we'll get that set up. So let's add this 1/8 inch end mill. So again, we're going to create a new tool, and I'm going to name this that DEL. So I know to delete this after, but this one's going to be T5 because this is going to go in tool slot 5 for me. And then I can put something like 1/8 end mill. Something very simple like that. And so when I look at it, I know it's 205 and it's an 1/8 inch end mill. So type, again, we're going to go to flat router and we're going to hit OK. So same deal as before. So the only things that I've got to change, I got to put 5 for my tool number, 5 for my height offset ID. Diameter, we can do 0.125 for 1/8 inch. We're going to stay 0 for the minimum, and this work depth, we're going to put 0.5 for 1/2 inch. And we are going to allow this to go into the auto select pool, and I'm going to say no to these, and I'm just going to leave this as auto select. All right, so the offset tool, I'm going to leave that. We're going to rotate clockwise, and this max depth per pass, we're actually going to go 3/8. So instead of 3 inches, we're going to go 3/8 of an inch per pass, and then I'm going to leave that as 0 for the add to cut through. So the feed rate here, so this first one, we're going to do 150 for the 1/4 inch, and then we're going to cut that. Actually, we're going to go 10 for the 3/4 inch feed rate, and then I'm going to do 75 for the descent rate, and then I am going to leave the spindle speed at 12,000 RPMs. And again, I'm not going to do anything down here. So if we edit this shape, if we go to, let's do, if we make that an 1/8 of an inch, or actually let's make this a 1/4 inch. What do we say? This is an 1/8 inch end mill, so actually 0.625. We need to make this a 1/16. Okay, so if we change this to 1/16 grid unit, we can see that we're good here, and we're good here with the other 16th. So we actually don't even need to edit that shape. It is, it's fine just the way it is. So we're gonna close this out, and now, I guess we'll bring it back up. Now we're going to go to the shape tools, and we're going to start adding these tools that are a little bit more complicated shapes. So let's add one of the shape tools. And what we're going to do, I'm going to come to the internet here, and we're going to add first, we're going to do this guy first. So this is the first of the shaping tools, and so it's the 7964. So if we come back into Cabinet Vision, let's create a new tool, and I'm going to name this, start out with delete. This one is going to be T9 because it's going to be tool 9, and we're going to go ahead and put, I'm just going to put the tool number for this one. So it's tool 7964, and I could even put something like this, like vortex. Maybe I should have put vortex before to break up the two numbers, but that's good enough for now. So let's go to type, and we're going to go to shaped router, and we're going to hit OK. All right, same deal as before. I'm not going to do anything here. We're going to put tool number 9 here, tool number 9 here. The diameter of this tool is actually, I'm going to go 30, it's in millimeters. I know it's 31 millimeters, and then in inches. So another thing I want to point out is your tolerance right here. It's how accurate you want it. So if we do like inch and 30 seconds, basically, if I do something low like this, in 1/16 rounding, it's going to round it to the nearest 16th. So we see it's 1 1/4 inch, but actually if we go to, say, a more accurate factor or rounding or whatever, we can see that it's actually not 1 1/4 inch. And actually this one is 1 3/16, so it's not quite 1.25 inches. So let's just put 3/16. And if we go to millimeters, we're looking at, it's about right in there. So we've got our minimum work depth. We're going to leave this at 0. I'm not going to do the work depth. Okay, so for our movement, we're actually going to change this to the center line. And that's because wherever I tell this blade to travel, I don't want it to offset. I want it to run right on the center line, and that just makes it easy if you have to start making offset adjustments. You're offsetting from the center of its path, and you're not having to figure out, figure out how it's cutting to the offset and then offset that, if that makes any sense. So that's why we're leaving that as the center line, and we're going to rotate clockwise. And on this one, I'm going to put 1 inch, because the blade, actually, let's go 2 inches. Let's just leave it that. We're not going to go that deep, but I'm going to leave it at that. So the feed rate here, we're going to do 300 for the 1/4 inch, 300. And again, I'm getting these numbers because I reverse engineered something that Cabinet Vision had set up. So the spindle speed, we're going to do it at 16,000 RPMs. I believe my spindle has a maximum RPM of 18,000. I think. So something for me just to keep in mind. Okay, so that is all of this information. So now we have to do the shape data. And this is where it gets a little bit more complicated than the simple shapes that we did before this. So before we do this, let's go ahead and click Edit Shape. If we go to the internet and we go back to this tool on vortextool.com, we have this product drawing and dimensions PDF. So we're going to pull this guy up, and we're going to kind of have this help us a little bit. We've got some information, like we've got the radius here, and I think it gives us enough to get it mostly done. The only thing that I don't see is it doesn't really give us a radius for these little notches right here. So I don't know if I'm going to worry about that too much or not. But to start, if we come in back into Cabinet Vision, let's think about this a second. So we're going to be jumping back and forth to this page into Cabinet Vision. So I apologize for the back and forth so much, but it's just easier for me to look at this and then jump back into Cabinet Vision. So the first thing that I want to maybe tackle is this guy right here. So if we're coming down our center line, let's maybe do this guy right here. And so if we have 0.466, and that's from here to here. If we go 0.233, that should get us this little dot here. So let's go 0.233. So I'm going to go to this grid unit, and I'm literally just going to put in 0.233. And let's add a point right there. That simple. All right, so now let's go back to this, and we need to make this radius. So we've got a radius here, and right here it says it's 0.375. So let's come into this grid unit, and let's put 0.375. And I'm going to disable snap to grid, and we're going to add another point right on that 375, just like that. And then we're going to come back here, and we need to go. So from here to here, we're at 0.1216, so we need to cut that in half. So let me whip out my calculator here on my phone. So I'm literally just taking 1.216 and I'm dividing it by 2. And that gives me 0.608. So if we come 0.608, 0.608, just like that. Now if we take, if we create a new point, just like that. Okay, so how do we get that radius? We're going to come up here to radius point. We're going to click this point, and we're going to type in 0.375. We're going to hit OK. And there we go. So that is giving us that radius. And it looks like, let me zoom in on this a second. Couldn't tell if that was a point or if that was just part of that radius. Okay, so we've got that radius. So let's go back here, and we've got this little radius here. And I don't really know. It's not giving me a radius. It's not really giving me a distance. So, you know, we could get away with either not doing it at all, or, you know, we could kind of like guesstimate. And again, this is for like X simulator, so it's kind of, you know, it's how accurate you want to be in the simulator. But if we try to put this in, so let's say this point 1281 is from here to here, and then this point 1216 is from here to here. So let's take that point, or that's that 1.281, divide that by 2. That gives us 0.6405. So if we come back here and we put 0.6405, then we know how far we need to come over, but it doesn't really give us a height to go up. So I'm just going to do an arbitrary number that looks like it might work, and we can move it. And we might have to zoom in a little bit here, and then let's add another point. Here, well, let's, and then we'll move this guy over here, and we can give this guy, I don't even know how much of a radius to give it, 0.05 maybe. Let's see what that looked like. Maybe that was too much. That looks like it might work. I mean, that will be pretty close. So we're gonna roll with that. So now let's go back and take a look, and we can see that it comes up about an inch or so, 0.009 from this point. I'm not going to worry about it too much. I'm just going to put an inch on the grid unit. And we're going to, we're just going to call that good. And so what I'm going to do is I'm going to put this guy right here. We're going to do another point like that. And then I'm going to move this guy, you know, above it like that. And I think, okay, I don't know why it put that point, but it removed, I'm going to remove that point. So this is, it's a lot of like, just like tinkering. Like I like to, you know, think there's a quick and easy way to do it, but it really is just a lot of tinkering. So now if I close this and I save this shape, we can look to see that it is definitely not perfect, but it's a pretty close. I would say it's pretty accurate depiction. I know we've got this radius correctly. We've got this the diameter, and we've got the you know, radius here. So, and then we've got, yeah, the overall. So we've got enough. It's accurate enough to where, you know, I would be pretty confident that this would work out. And if we come in here, we can, you know, we could maybe go in and tweak that a little more, but I'm not even going to worry about it for this. All right, so let's move on to the next shape tool. And now we're going to take a look at getting this guy into the library. And so this is tool 7965. And again, we're going to come down here to the product DX or PDF. And let's take a look at what we got. So we got the whole tool here. And we've got, let's just zoom out just a little bit. All right, so we got some information to work with. So let's go ahead and create a new tool and quickly give it a name. So we're going to put DEL. This one's going to be tool 8. And we're going to call this Vortex. And this is 7965. Let's make this a shaped router and click OK. And so let's quickly go down the list. This is going to be 8, 8. So the diameter, I'm going to go with this 0.581 because we're only cutting with this shape. So, and maybe this is a radius. I don't know. I really don't know. So this 0.581 is what I'm going to use. And when I reversed engineered something that a Captain Vision tech had set up, they had 13/16. And this actually equates to 0.581. It should be 9/16. So the last one I saw had 13/16 for this, but we can do 9/16 because that's what that says. And I might be wrong, but let's roll with that and see how it goes. I'm not going to change that. I'm not going to change that. Let's make this output on the center line. We're going to keep this rotating clockwise. Just put like an inch there. The feeds, let's put 300 for the quarter, 300 for the 3/4, 150 for the descent rate. And on this guy, I'm going to spin it at the spindle speed of 16,000. And these numbers here I also got from reverse engineering a setup that a Cabinet Vision tech had done. So I'm just going to assume they know what they're doing. And so that's why I use these values. All right, so now we're going to get into the shape editing of this, and you may see me struggle here. So let's see what we can do. But no promises that I can get it done in the first go. But let's just get started and see what happens. So it looks like we've got some dimensions from this tip here. So I'm going to start at this tip, and then we're going to work our way to the right. So the first thing I'm going to do is I'm going to take this 0.030, and we're going to zoom in on it. And this is where, I wish this thing went full screen. It is just frustrating that it doesn't, but let's add a point right at this grid. So we just basically want one grid space over, and that's going to give us our little point. So now that we have that, we have this radius of 0.375. So let's go here and put 0.375. And I'm going to turn that off. Let's zoom in. Well, let's see if we can kind of zoom in on this region. Maybe that was good enough. So I'm basically going to add a point, and let's go right above it at that line of 0.375. Just like that. And then I'm going to go over to the right to this 0.4, or right here. Is it this guy? So is it this guy? And right here, I think this one is the 0.405. So let's go 0.405. And let's take this guy. Actually, we'll just move this point where it's in line with that guy, but on that line. And then let's give this guy that radius of 0.375 and hit OK. All right, let's see if we're getting any closer. Okay, so... All right, so we've got this, we've got the radius, and then now we need to come up. And then we've got this little radius here. And I don't know how high this point is, I don't think. I don't see anything, but we know from here off the center, maybe it's that 0.491. So I'm going to go, I guess I'm just going to kind of guesstimate maybe 0.125 distance to go up. I mean, I guess I could get calipers out and I could go get the tools and go get some calipers and measure this distance, but I think for this I'm not too terribly worried about it. Let's say that this is like maybe like a, let's see if we can deduce like a 16th or something. Maybe like, maybe I will have to get calipers eventually, but I'm just going to kind of, let's just say like a 16th for now, or maybe even like an 8th. Let's go back here a second. So this, yeah, let's just do like a 16th. Maybe. And let's take, okay, so how am I going to do this? So I think actually here, so here's where it gets a little tricky. I can't really move this point, I think. So let's move that guy to there. So it kind of overshot it when I did the radius, and so it was going to move it wonky. So I moved that point out to it, and now, no, I keep zooming in and out. It's probably confusing. So now let's add a point, and let's just go like right here. Maybe right on that line. Well, and I keep adding a point when I'm doing that. We want to move this point. We don't want to add. So just keep that in mind. Yeah, every time I click that with the plus, it adds a point. Okay, so let's just we'll just kind of keep that for now at that 16th. And then if we come here, I know that right here, so 0.491 is the distance from here to where the edge of that is. So let's come here. Let's go 0.491. And let's zoom in. And let's add a point right there. And if we zoom out, like, I don't know, maybe that's not quite tall. Maybe that needs to be taller. So let's actually, I'm going to move this up just a little bit. Again, I'm not like ultra worried about this shape. I mean, once we start running it, we're going to really figure out like if we're close or not. So then now let's put a little radius on this guy. And again, I have no idea what to put. So let's put like 0.05 maybe. Something like that. I think that looks pretty reasonable. And if we go, so the last thing I got to do, so we're going to do this point. We're going to do this point, so 0.581 first. So let's put 0.581. And we know that we're going to come out. Let's add a point. Okay, let's just do this for a minute so you can kind of see my my reasoning. So we know we're going to come out like that at the angle. But, you know, I guess I would need to get calipers, and maybe I should have had calipers to do this. Well, I'm making, you know, this video because maybe it looks like I don't know what I'm doing, and I probably don't for the most part, but let's just say that this, so if this is, you know, basically like an inch, maybe this is like a ½ inch. Maybe that's just straight. We're just going to call it, we'll say, we'll do this. Let's go 3/8, maybe. And actually, well, what I need to do, I actually need to leave it at that 0.581 so I know where I'm at there. So we'll just lower it on this line, maybe. I don't know, something like that. Something like that. I think that's going to be good enough for me. And then what we can do. So I'm not even going to go into, like, there's no need for me to really design anything beyond the point that we're at. So to finish it off so it looks nice, maybe we just come in like... So we could do something like that, and then if we close and save it, we can see that more or less we have the shape of our tool, and you know, we've got that little tip there, and then we've got that little so I think between tool 8, let's see, tool 9, tool 9, that looks really close. Tool 8, I think that looks really close, and in fact, it's more than close enough for us to get started running it in the real world, and then, you know, we can you know, make changes that way. So I think we're good. So now we've got all the tools in. So the last tool, I'll cover it. I'm not going to put it in since I already have it in. It is my T4, that 3/8 compression, this guy right here from Nick Frost. So I'm just going to throw this one for the sake of time on this video. This is what the information I have for this compression. So I'll just go slow. If you want to pause the video and look at it. These are my feeds, my speeds. These are what I use day in and day out, and I wear these mofos out. So, you know, if you're running a similar machine, this ought to get you, you know, do you pretty good. So, all right. So now that we have all these tools in, we can move to creating a tool set. All right, let's start making this tool set. And before I get started, we're going to come up here to the tool right here, and we'll open up this catalog. But before I get started, I just want to reiterate that this is something that I just came up with that worked for me from trial and error. So if you guys are, if there's any of you pros out there, don't beat me up. This is, you know, if it looks funny or if there's a better way to do it, this is just what I have found that works for me. Secondly, there's a chance that I might run into this little bug that I have recently discovered setting up a tool set. So if it does show up, then I'm going to show you what I found to work around it, but it may or may not work for you. So let's come up here to create a new tool first, and we've got name and type, just like we did when we were setting up the single tools. But for this one, I'm going to name this delete. And then we're going to do V groove, or actually this is not V groove. This is like, let's do shape. I'm just going to do something so I know to look back, video test. The name is just irrelevant. It's just for me so I know to go back and delete this. But, you know, whatever your name is, name it very specific to, you know, you want it to be memorable and want it to make sense. All right, we're going to click tool set, and I'm going to hit OK, and here we go. Okay, so this This is a problem that I have run into, and I've only run into it on 24.4, and I have no idea what's causing this. Sometimes it works, sometimes it doesn't. Sometimes I don't get this error, but recently it's been popping up every time. So if I hit OK and I hit OK, it'll still let me get in on it, but it will not work. So what I'm going to have to do is I'm going to delete that. And for the sake of this video, I'm going to grab the shaker door set. So this is my standard shaker door, and I'm going to copy it. And then I'm going to go in and we're going to delete everything out and change it. So if you are able to go create a new tool set and you don't get that error, you're probably good. If not, hopefully you have some other door profile set up where you can just copy it and then change it. So let's go ahead first thing and let's just rename this. I'm just going to name this DEL for delete, and we're going to do I'm just going to do form tool or shape tool test, video test. And that is just so I know to go in and delete that. Okay, what I'm going to do here is we're going to go to edit shape, and I'm going to delete out all the tools that are in here so that we're starting at a clean slate. So this is exactly what you would see when you first come in. And so it's blank. We've got our name, and then if we go into edit shape, we have nothing here. So in edit shape, this is, yes, the edit shape, this is where we're going to start bringing in all our tools and basically building the set. Before we start adding tools, I just want to talk about the different ways that you can go about this. So when I did this the very first time, I did not use simulation that is built into Cabinet Vision. So when I first did it, I would make a change and then I would have to run it and then analyze it and make adjustments. But we're going to use X simulation or simulation. And so to see if you have that under your license, you have to come up here to the little question mark, come to license details, and if you see simulation down here, then you have access to it. If you do not have access to it, it's not the end of the world at all, but it just can save some time getting it set up in the simulation. It can save some time, from running back and forth to the machine. So we're going to use it, but you do not have to have it. It just does make life easier. So if we go with this form tool video test, we can start building out our set. So the first thing we're going to do is we're going to add a new tool. So we're going to click this, and it is going to just throw in a random tool, or it'll throw in a tool, and it may be what you want. It may not be. It just throws it in, and then from here you can actually drop down and select whatever tool you want that is in your library. In our case, it is exactly what we want. So we're going to use this one. And for the sake of time, because I know this video is long, I went ahead and I made some notes from a set that I already know works. So I'm going to go through these, and then we'll check out the simulation in between each tool. So that way, even though I'm not doing it, from scratch necessarily, because that would take way too long, you can get an idea of, how you go about this, hopefully. So the first tool we want is this Diamond Hog. All right, it's going to ask us some stuff over here that we need to tell it. First thing is the offset. This center line, whenever we bring this router into the world, and I'm going to have a little 3D video here that hopefully helps you see where this is coming in the process, like in 3D space. So that way, for all you visual learners out there, you can get a sense of like how we have to offset this, because where it stands, the center line of this tool is lining up with the edge. It's in line with the ledge or the edge of the shaker profile. Okay, so obviously we have to move that over, and we have to move it over, a specific direction. And if you've never done this before, I encourage you to just start putting some numbers in there to see the way that it's moving. So if we move it a ½ inch, it moves to the right. If we go -5, it moves to the left. If we zero it out, you can do the same for all those other ones so that we get a sense of how you're moving it. So we need to offset this. We need to offset it to the left. So how much do we offset it? Well, if we think about this logically, we want basically this edge to be over here, so we need to shift this to the left. And we are going to shift this guy to the left 11/16. And that is what I use currently. And the reason that there's a gap here is because, like, you'll see that this is not right on the line. Well, as we add tools, it's going to take material off. And so we're having to account for all of these things. So we're going to use a -11/16 for the offset, and the depth on this, we are going to come down 7/16. All right, so for the depth, whenever you're doing a shaping tool, it's important that you know the depth. If you have no reference and you're building a set from scratch like we're doing, these tools that have a shape, there's a specific depth that they have to go down to maximize the full shape of the blade. So, we have to make sure that we're going down far enough to capture that full shape. Otherwise, it might look incomplete at the top, or if you go down too deep, it looks like it's going too deep and you have a ledge. Hopefully that makes sense. So on our drop offset, we're going to leave that at 0. We are going to say no for cut for glass. Operation, this is going to be a pocket. And immediately this turns gray, symbolizing that we are going to take out all the material to the left of it. And then we want our reference, our depth, to be a fixed depth because we want it to go the depth we're telling it to. So we don't want any calculations beyond that. So if we hit close for a minute, I'm going to close this, and we're going to just take a look in simulation one by one each tool, so that way you guys get a sense of like what it is we're doing. So if we go to cabinet, let's go to door. I've got my MDF shaker here on our route path here. This is where I'm going to select this delete form video. And this, when that error was coming up, even though I had a tool set, it was not displaying in this drop down. So I sent Cabinet Vision over, all the documentations of what's happening. So whenever they get back to me and we get a solution for that, I will make an update video. Okay, so if we click OK, let's go ahead and just throw a really quick cabinet in here. Object, custom cabinets. Let's just do a wall. And I'm going to make this something simple. Single door. We'll just do 20 by 30. All right, and okay, so I'm going to go ahead and save this just in case Cabinet Vision crashes, because sometimes it does here lately. All right, so let's go ahead and jump into Screen to Machine Center. And when we go to the X simulation, we should only see the tool 11, or that hogging tool. All right, so we are in Screen to Machine. I'm going to check this box. And I apologize if I'm talking fast. I'm just trying to move through this. So if we hit run, I've got that selected. We're going to run that. Let's take a look at what we got. So here is where, if you have machine simulation under your license, this is where it's going to show up. And if we click that, it is going to pop up. It's going to pop up the simulation, and we can see it's pocketing out, which is what we want. So we can look down here at the bottom left, and you can see the tool that it is calling out. So you can double check to make sure it's calling out the right tool. And let's go ahead and speed this up. All right, so we can see that it is doing exactly what we want, and it is just the hogging, so it will maintain the exact form of that tool. So it's not going to do anything beyond that. All right, so let's exit out of this, and let's go back into our, we got to save this, and we're going to have to close out of it. You might be able to do this inside of Screen to Machine, but I always close out of it whenever I do any of the changes. So let's go back into that delete form tool video test that we have, and we are going to add in another tool, and this one we are going to use this tool number 9. All right, so this is our the tool we're bringing in, and I don't. Oh, that's just the edge of that. I was like, what is this little thing down here? Okay. One thing to keep in mind when you're doing this, it is very important the order that you bring these in. And you can move them around the order tree here, but we want, like I've got 11. I need this to be at the top because I want this tool to be first. Now I want this tool to come in behind it. So the same deal as before, we have to come in and start giving it offset, depth, and an operation type. So this guy right here, we are going to offset this guy -1/4 of an inch. All right, and so if you can kind of see, so we need to get the entirety of this blade in. And again, we're just kind of getting a good base going, and then we're going to run it, and then, we can make any adjustments. But we need to make sure that we are clearing some material off. So that's why I'm going 1/4. The depth, we're going to still go the 7/16. We are not going to do anything on the drop offset, the type. We are going to do this one's going to be, it's going to be a rough pass, which means it's going to go all the way around in a line. And we are cleaning up the right side. So we want that right side. Well, the tool's it's cutting on the right side, so we need clean right. And at the same, we're going to leave the reference at fixed depth. So now if we close that out, let's go back into the video test. We've got to save it, and we're going to have to update the doors, I believe. Okay, so now if we go back into Screen to Machine and we run that same process, we should see after it calls the tool 11, it's going to call tool number 9, which is the rough. That is the rough first shape of this profile we're doing. Okay, so we're going to go back to that door slab. We're going to optimize again. And let's go back to the machine simulation and see if it... Might have to click that first so it knows what to simulate. All right. So let's speed it up. All right, so it looked like it grabbed that tool, T9, so that looks pretty good. And the accuracy of this 3D shape, that goes back to, when we set it up in the tool. So that's where, if you're using simulation, you want to be pretty precise with how you set that up, because it'll make your life easier in here. So, and if you don't have, just to reiterate, if you don't have simulation, this is where you would go out and run a test part. And you just don't move it, you leave it there and then rerun it every time you make a change. So let's go back into, let's go to cancel, save. Let's go back to our tool set, and all right, now let's go ahead and add in we're going to add in T8. All right, so this is the tool that's going to give us the finishing. It's going to finish this shape out, and so I'm going to refer to my notes here. And this guy on the offset is, we're going to do this in 30 seconds because that's what I wrote down on my notes. But we're going to move it over a 30-second. So negative 1/32. We're still going to go the same 7/16. Actually, we don't want that is 0. Here is 7/16. Just like that. And this guy is also going to be a rough, also clean right, and also fixed depth. And the reason, so kind of the offset, you know, the idea here is that you want the tip. This tool comes to a pretty fine point. So, you know, you could start if you're doing this again and you have no clue what you're doing. If you started wherever this guy is and you dropped it down right where, so like you could start out with the same offset. Is this guy like -1/4, and then drop it right down where that one ends and then run it, and then you'll be like, okay, well, I need to move it over a little bit more to the right to clear material again. So, you know, nothing wrong. Like if you don't know what you're doing, you can drop that right down where the last tool left off, and that'll give you a real good idea of where it's landing in the real world. Okay, so let's go ahead and close this out. I know this is a lot of back and forth. I apologize, but, you know, I'm trying to do this in a way that, you know, you guys can get the most out of it, because I spent a lot of time trying to figure this stuff out. And so I guess I'm trying to tell you guys all the things that I wish someone told me, you know, when I was first messing around with all this stuff. All right, so back to the door slab. We'll optimize. All right, speed this up. Oh, that looks good. So now we've got our finishing pass. And so what it's showing here is that, you know, in the real world, I mean, in the computer, it's saying, you know, as it's going around, you know, there's going to be a little bit of material left in the corners. But from my experience, that stuff gets knocked off in reality. And if there is a little, you know, you can hit it. But I think that's pretty good. Again, this is all a starting point. You know, we're trying to get to the best possible starting point before we go out and fire the machine up. So that looks good. So let's go. Okay, before we move on, let's kind of talk about where we're at. So we've got the main hogging done. We put in the pre-shape tool, and then we put in the final tool, or the second shape tool. And now down here, the corners look probably okay. They're passable for sharpness. Up here, we don't want these rounded corners, right? So we can definitely work to clean these corners up a little bit. And so that's what we're going to do now. And we're going to use that 1/8 inch end mill to do it. So if we back out of here, save this, and we're going to close this again. And I'm actually going to, everything's been running really slow here lately. Let me just see if I can restart this a second. I don't know. The 24.4 just seems to really choke my machine up. And I've got a pretty decent computer, and it just, for some reason, it just, I feel like compared to the last Cabinet Vision, this one just runs a little slower. Okay. All right, so that seems a little faster. So hopefully that helps. All right, so what we want to do now is we're going to edit the shape, and we are going to drop in In my case, this Delete Tool 5, this end mill, and we are going to use this guy in the corners. So we're actually going to use this guy twice, two different sets. So let's set the first guy up, and we are going to offset this guy 3/8. All right. And we are going to go a depth of, I think a 16th is what I have. So 0.065. And we are going to use this guy as a cleanup. And the radius to clean up after largely depends on the diameter of your hogging tool. So that radius is what the hogging tool leaves behind to get. So it's like if you run, I guess an easy way to do this, if you don't know what it is, run a piece, take a ruler and draw a line to where if the corners were sharp, and then you can see all what you would have to clean up in order to get that clean. Hopefully, if that makes sense. But on this guy, we are going to clean up after a radius of 5/8. We're going to use that. We're going to stay fixed depth. And let's close this guy out. Same deal. I'm just going to update. Just to make sure. And I'm actually going to shrink this. Let's do 15 by 15 just to speed this thing up, because we're going to run this and I don't want it to be too big. All right, so let's go back into screen to machine. All right, so get this door slab again. Let's optimize it. All right, so let's see what this cleanup on the 1/8 inch does. All right, so let's zoom in here. And let's speed this up. And I'll try to slow it down. So that's okay. So I'm going to try to slow this one down a little bit so you can see what we're doing. Okay, so here is the cleanup. So you can see what it's doing. It's basically going into the corners, and it is going to, it's basically going in like a normal cleanup pass, and it's just sharpening those corners. And that looks really good. The only problem we have now is that it leaves us this little edge here, and that's why we're gonna do another one to clean it up. And let's go ahead and let's do that. So let's save it. Let's close it out. We'll go back to this delete form, and let's go ahead and add another one. This guy, we are going to offset him. We're going to do 3/8 offset. So the same offset there, and I think we're going down the same depth. We're going to leave it at a rough pass because we want it to travel down the whole inside. We're going to leave it at a fixed depth, and we're going to hit close. And that is all we're going to do there. Let's go ahead and update this. All right. Save it just in case she crashes. And I did talk to one of the engineers, I guess, working on hopefully the next version of Cabinet Vision coming out. They said they have greatly improved, or the screen to machine is supposed to be greatly improved, and they said the loading time will be so much less than what it is now, because it is a problem, and it doesn't really matter how fast your computer is, it still seems to take forever. But good news is the new version should be fixing some of that, so we'll just have to see what it does when it comes out. Okay, so door slabs, same deal. Optimize. Okay, machine simulation. So let's see what this, Okay, so let's speed this up a little. And what we're going to see is that once this guy's done, he's basically going to travel around the inside just like that. If we pause it here just a second so I can zoom in so we can see what it's doing. And so it's basically just traveling along and going to get it nice and clean. So in theory, whenever we run this, we should have a relatively good looking door profile, and we're going to go run it and see after this. And again, you know, this is where you're gonna have to probably run it once or twice in the real world to see, you know, do I need to make some minor adjustments, you know, here. And then again, you know, you have to balance the changes you want to make inside of cabinet vision against the changes that need to be made on the machine side. You know, just depending on how accurate your tools are over there. So, you know, it's just all the stuff you have to keep in mind. But I think we're at a really good point, and hopefully this kind of shows you the power of simulation and how you can pretty much, you know, without even going to the machine, we have gotten to this point, which is a great starting point. It's easy to make changes and jump back into simulation than it is to go out and run actual parts. So you definitely don't have to have it to get by, but it definitely makes life easier. At least for me, it makes life easier. So, all right, now that we have this, let's go ahead and get this guy ready we're going to run this guy as a test. So I'm just going to put test right here. We're going to generate some code. Just going to do this really fast. So I'm going to print out this pattern sheet so I know what it is I'm looking at. All right, and then I'm going to throw this code out to the machine. And we are going to go run it. So we've got the code in the machine, and so I will see you out there at the CNC, and let's go run our first test and see how close we land. So right as I was coming out to the machine to run this part, a thunderstorm decided to show up, and unfortunately my roof is tin metal, so I apologize for the noise and the flickering lights, but I did not see any lightning. So we should be good. I'm still going to try to run this. I've got my scrap piece of board here. So let's run this this test. I'm going to fire the machine up, and we're going to see you know, what we have on our first pass. got this guy ran, and overall it came in close enough that I could use this pretty much as is, and send it off for sanding and get it painted. Obviously I have done this setup before, so I knew the numbers to plug in. However, the same process that I showed you is exactly how I went about it when I first set it up to begin with. So even though I might have skipped over a lot of the the trial error moving stuff, tweaking, making small changes, hopefully this gets you a pretty good idea of what it would take to start just experimenting on your own, because once you do, I think you'll find that it's a lot more fun and not as hard as you realized. But I do want to mention a rookie mistake that I did when I ran this. I forgot to push this all the way up against my indexing pins, so this did not come out square, unfortunately, but it did bring up what I want to talk to you guys about as far as getting your thicknesses on your stile and rails all the way around. So when I initially did this for real the first time, I focused on getting it to this point to where I knew the profile was good. Once I got to that point, then I measured my stiles and rails all the way around, and I had a number that I was shooting for, which was 2¼ inches, and I would measure what I had and weigh that up against where I needed to be to get it to 2¼ and then I would offset all the tools the same amount, whichever way they needed to go. If they were too small, I would move them in, but I did all of the tools together the same amount. So that's kind of how I reason through stuff like that. So I get it set up, get it running good, and then I can offset the whole set as a group whichever way I need to go to make the proper thicknesses that I want. So I'm gonna wrap it up there because I know this is a very long video, and I just want to say thank you if you watched it this far. I hope this helped you guys out. I know I probably skipped over some of the little changes that I probably made the first time around. However, I didn't want this to be like a 5-hour video, so I tried to condense it down to where I was including as much of the information I can, whereas not dragging it out. So again, thank you guys for watching. I hope this was helpful, and we'll see you in the next video.